Hello, everybody, and thank you all for attending today. My name is Zina Farouk, and I am our Geotechnical Application Specialist for Oasys. I'm also a geotechnical engineer, and I'm really excited to share with you today the new developments on Oasys Slope. It not only looks very different, but it does different things as well. So I'm going to introduce those new features that I'm going to talk about today, and also set up a live analysis for you, showing you the new user interface. So Slope is a long-standing program. We're very proud of what it's done and how it's helped our customers. It's a limit equilibrium analysis for circular and non-circular slip surfaces. It analyzes reinforcing elements. It incorporates partial factor analysis. There are lots of features that are heavily used in Slope, and they're all available in the new version. But additionally, we've got the Morgenstern-Price Method, which has been requested by the Australasia region. We understand it's heavily used there, but it is used elsewhere as well. Consolidation and seepage analysis can now be run because pore pressures can be calculated as well as specified. We've got the ribbon interface, which is a new interface that I'm going to show you today, and the graphical input feature is just really quick, and I will show you how to run with that. So to start off with, we've got existing methods available for slope. So we've got the Bishop's method for circular slips, and we've got the John Bow method for non-circular slips. But we now have the Morgenstern-Price method working within slope, and it is based on parallel inclined interslice forces, and there is a function within to express a varying ratio between the normal and shear interslice forces. In terms of groundwater analysis, you've got your standard hydrostatic distribution. We allow for piezometric pressures and RU values as well. So that was all there in the previous version, but you can now carry out steady state seepage analysis. So the user will apply groundwater and seepage boundaries, and then based on that, the program can calculate pore pressures. So in terms of calculating pore pressures, the strength of slope is its simplicity. So using the method of slices gives you a quick and thorough analysis. But we now incorporate FE seepage analysis for the groundwater distribution. So it's the best of both worlds, really, because you can easily specify slope strata and material, so it's much easier than using 2D FE analysis. But you also have the option of specifying groundwater flow and head boundary conditions for seepage analysis. So this just gives you an idea of the kind of options that you have for boundaries. So here you can see the different nodes represent different boundary conditions and free flow down as well. And based on that, you get these pore pressure results. So this shows the pore pressures, but you still have the standard circular slip showing there. So in terms of graphical inputs, that's a new option, but we have all the other existing options as well. So you can look at the layers of material and specify the strength of materials in similar ways. Groundwater, you can choose to work with your existing options or try our new inputs. Reinforcement is still there. That's not changed. The external force is also much the same, as is the slip surface definition. So I'm going to run a demo now to show you how to set up the material and water properties with the new interface. We're going to input Strata using the graphical input feature. We're going to apply some surface loads, so keep it really simple, and run the analysis and examine graphical outputs. Now, the reason I'm just doing something very quickly today is because it's a taster session, but we are coming up with some training webinars over the next 2 months, and that will go through, for example, more detail on reinforcement, partial factor analysis, the Morgenstern-Price method, and pore pressure calculation. So that is all coming. Right. So let me transfer over to the new version of Slope. Okay, so this is our new interface. As you can see, we've got the ribbons at the top here. So I am going to create a new file. So as with the old version of Slope, we've got the gateway to the side. We can still do most everything that you could do with the previous version. All that is available here. So we'll start with the titles. I'm just going to say webinar example. Okay, so the titles are important because they do come on the printouts. A specification is worth having a quick look at. So a lot of it is again similar to what was there previously, but we do have the Morgenstern-Price method, as I had explained. Partial factors are the same as previously, but it's always worth noting because that's something that people do ask about. And as well as specified pore pressure calculations, there are the calculated option, which again, along with the Morgenstern's price method, I will go through in much more detail with our training webinars. So as usual, we have all the reinforcement options, and reinforcement is again something we'll cover on the training webinar. So let's set up a problem very quickly. So the material tables are much the same. So we'll start with an embankment overlying a foundation and bedrock. So let's type in here embankment. So this is the soil properties. So we'll get this from some site investigation normally and some level of engineering interpretation. Okay, so the foundation soil is going to be stronger. So we'll give that a unit weight of 18 above groundwater, 21 below, so drained. Again, we've got the grey options, which you could tab across at the top. And I'll go for bedrock. So 22, 24, and I think we're going to make this a very strong, almost rock-like substance. So there we go. So that's the materials. Let's put in the water data. Sorry, excuse me, little sneeze there. So GWL, let's go for hydrostatic. So we've got piezometric and specified RU, and the other options come if you put in calculated for pore pressures. So 0, 11, 15, 14, 35, 4, 35, 3, and 53. Okay, so these are the groundwater level properties. So we are inputting, the developers are putting in the polyline feature, which allows you to basically put the X and Y coordinates in there as well. Right, that groundwater level looks slightly off, so I must have made a mistake. So I think I was meant to put this as 1510. So it's good to know that all the corrections can be rectified very quickly. So that's the graphical input feature that we're in now. So I've double clicked on the gateway for that. So instead of using the polylines to just put in the coordinates, which is very similar to what was previously offered in Oasys Slope, and there is also the DXF import option, I'm going to use the new graphical input feature. So let's go from -20 to 60 to see the extent of our problem. So this sets the minimum, maximum X and Y values for plotting. So the lines are used to represent the strata, and then you join the lines to create areas. So as you can see, it's really easy to click. I just clicked there on 014. We'll go to 1514. Again, very easy to just click. And if I right click now, I can actually type in the coordinates as well. So 35,4, and right click again. Oh, I'll just click it on here, and 54, right? So I finished that one strata. I'm going to press escape now. I'm now going to put the base of the embankment. Again, I'm going to go for a line. Now you may be wondering, why do I click on the line every time? So as you can see, I'm snapping to this point here, so I know it will join. So you may be wondering why I create a new line every time. It's so that I don't accidentally create lines by clicking in areas. So every time I create a new strata, I just quickly click on line. Another thing by snapping to points is that you don't go over a point. So previously in slope, for example, you could accidentally, for example, put a point up here. So this new version of slope, if you snap 2 points or snap 2 lines, that really does help. And I'll put a new base to the bedrock as well. So previously in slope, we didn't really need to think about the base, but because we need a mesh for the pore pressure calculation, that's in there. So if I close the area now, right, material 1 was specified as the embankment soil and groundwater level. And go for closing this area as well. So every time once I've created a line, I just press escape and that line's completed and created. So it's really simple and quick to do once you're used to it. Material 2, groundwater level, okay. And let's go for, and again, I'm pressing escape. And I'm doing this quickly because you can see I'm just snapping to the point, so it just makes life that much easier. So again, can you see that little square in the corner that's hovering over there? And let's go for material 3, which was the bedrock. So this is also going to show in a different color, and those colors are going to align with the material colors that we specified earlier. So we also need to tell the program where to calculate our slip circles. So I'm going to go for the grid option because that's easier to find the minimum factor of safety. So let's go for a grid at around 2510, so starting around there, so 25 is the X value, 10, and I would like it to be reasonably parallel to this slope here, so that's minus 25 degrees. Okay, so we need a decent number of points for a grid, so I'm going to say 15 on each. If we go for too many points or make the grid too big, the calculation does take a long time to run, so just be aware of that. But just so that I don't miss the minimum factor of safety, I'll say extend the grid. So this is also very similar to what was previously available in slope, but it's always worth running through the theory again for you. So just to show you, we have the reinforcement options available as previously, but I won't go through it in too much detail today. So let's put some surface loads in behind the walls. So again, this is the same tabular input as was available previously in slope. So we'll have a vertical load of 10 kPa at the top of the embankment. Right, so let's just check my graphical input. It's always good practice. And let's also save this file at this point as well. So I'm going to save this as webinar EG. Right, so I've had a quick look. This seems reasonable. So let's do the analysis. So the analysis box will open. And if you click on Start, you'll see the analysis progressing. Right, and it went from an orange in progress to a green completed. So that's all run. So if I double click on graphical output, the graphical outputs will show. So we're having a number of results showing here. So what I'm going to do is I'm going to say, let's have a maximum factor of safety of 3. So that picks up our slip surfaces much better. So you can see the minimum factor of safety is showing, which is 1.047. And we can show multiple slips as well. But if you wanted to see the minimum factor of safety slip, that's this slip surface here. We also can look at the slices, look at the slice diagrams, and I will go through the pore pressure outputs and various other things when we do our training webinar, which is coming. So as you can see, there was quite a lot I did in a very short time, and that was possible because of the graphical input feature. So it is now quicker to set up something in the new version of Slope, but it's just as powerful. It's got more methods in it as well. So, I'm very excited about what we're able to offer. Right. So now I've demoed the new version. a little bit of information about training and support that's going to be available for it. We've put together a tutorial manual. There will, as usual, be the user manual. We also have mini tutorial videos to help you set up an analysis. You can always email us if you need support or if you have any suggestions following the webinar as to things that you would be looking for in the program. And we will be running 2 training webinars to cover pore pressures and new methods, as well as going into more depth with things like partial factors. But we do full sessions for training as well. So if you want that, that's an offering that we have and is quite popular right now. We are also doing online training. So do get in touch with us if that's something that you're interested in. Right. So I hope that you're as excited as we are to see what's available in Slope. Today I covered the new features and I also set up an analysis live with you and showed you how the new UI works. So do let me know if you have any questions now. I'm happy to take any questions you might have. And please do get in touch with us or email us at oasys@arup.com if you have any questions following that. Thank you for your time today.